Okay, so driving into school this morning, I thought of a good analogy to help you understand why this has a higher boiling point than this. So this is a little review from yesterday first. What did we write in our notes, or what do you guys remember? Why does this have a higher boiling point than this? What did we write down?
There's more
what?
force of attraction.
More forces of attraction. Why are there more forces of attraction here?
More bonds.
No, there's more.
There are more bonds, yes.
There's more particles.
Yep. More atoms, yep. Something else. More dispersion force is good because there's more of these. Carbon atoms. Electrons, yes, very good. There's more electrons in this, and that means more electron movement, so more forces, more dispersion than here. But what I thought of this morning was zippers and Velcro.
Nope.
This will help.
This
If instead of just memorizing this stuff, I like it if you understand it, right? So that's why I think of these things. So if you take, just watch, if you take ethane, so there's ethane. It's attracted to another molecule of ethane. So let's say these two are attracted to us. Say that's the attraction there, okay? In order to boil ethane, you have to break the force of attraction. So when you have two ethane molecules together, near each other, attracted, that's kind of what it looks like. If we have something like, what would this be called? This is ethane, what's that called?
That is called, what's 1, 2, 3, 4, 5, 6? Okay.
5.
5. It's called pentane.
Pentane. So if we have two pentane molecules attracted to each other, okay, this has more atoms, more electrons, more dispersion forces, so you have to break that in order for it to boil, so it needs higher temperatures. So maybe that's good enough and you understand that. But I'm going to just explain it a little bit further, especially anybody who wants to take AP or college chem. Here's the deal. These would be kind of like, imagine you had a jacket or a coat or whatever, and you zippered all of the zippers. From the bottom to the top, your jacket would stay closed. This would be only if you zipper the bottom. You'd have, your stuff hanging out here. So you don't want your jackets open, okay? So you want to zipper all the way up. Why? So all the zippers are in contact with each other. That's stronger. If you only zipper a couple pieces or a couple teeth, or think of Velcro, put a little bit, just a few pieces together, it's not as strong. So the more Velcro, the more zippers that are actually overlapping, the stronger it is. And that's actually a pretty good example, because in real life, with this chemistry stuff here, the more particles that are touching, what do we call that? When more of it's exposed to touch. Surface area. If you have more surface area, that means stronger forces. So if you have long carbon chains, all right, like if I put my arms together here versus just my hands, there's more of my body touching here. So more longer means more surface area, means harder to rip apart. So I just thought that was good, because sometimes I struggle with ways to kind of give you analogies of real life things. So that's exactly why the longer these things get, the higher their boiling point. Not just the forces, that's good. You need to know that, but why? Why do the forces increase? Besides what I said yesterday, it's that surface area. So that contact, there's more contact here. So hopefully that makes some sense. Yes, that is what I think of sometimes driving in the car, chemistry stuff. But not always, just sometimes. So if that helps, good. If not, then I hope you understood what I said yesterday. All right, so that's that. Now, yesterday we left off with what? What was the last thing we drew? I forget. Just one example, right?
We drew
like
propane.
Propane or something?
Yeah, we drew propane.
Just propane, that's it.
And butane.
And butane, okay. So draw this for me. Yeah, I'm going to draw two. Draw this one here, and over here, draw this. Don't forget to put your dashes in for the hydrogens. Sometimes I get squirrely here with my lines, so I'll try and fix it. So again, these are called structural drawings. So you should know what structural means. If I say draw the structural drawing of propane or whatever, you should know that means show all the bonds. I'll show you what condensed means in a minute here. Okay. So we drew this yesterday, correct?
Yeah.
Okay. How many carbons here?
4.
4. Evan, how many carbons here? 4. Very good. Okay. What's the name of this?
Butane.
Butane. What's the name of this? Not butane. Why?
Because it's the way
It's not a straight line. Doesn't look the same. So I'm going to teach you today how to name these things. This thing is called a straight chain alkane. That's what it's called. A straight chain alkane. So it's in a straight chain, straight line. This is called a branched alkane. So think of a tree trunk and then the branch is coming off of it. So look up here. Here's our tree trunk and here's our branch. Okay? So this is where we're headed. These are a little bit more complicated. So I'm not going to really do anything with this. I guess I didn't need you to write it. I apologize. But this is where we're focusing today. So I'm going to show you how to name this right now. So really pay attention the best you can because the first time you learn it's probably the most crucial. So here we go. If you're given a structure like this, and I want you to name it, the first step is you have to count the longest chain of connected carbons. What does that mean? This one's connected to this one, and this one's connected to that one. So 1, 2, 3. These are connected in a straight chain. However, you could also turn here. All 3 of these are connected as well. So 1, 2, 3. Or 1, 2, 3. Or 1, 2, 3. Or 1, 2, 3. Or 1, 2, 3. No matter how you count it, 3 is the longest connected chain. So when I say chain, I mean bonds between carbons. So you count the longest chain, I'm going to say 3, and I'm going to put a box around that longest chain. Everyone do exactly what I'm doing. How you learn this. Okay. This is called, there's 3 different names for it. This is called the main carbon chain, so the main chain. Sometimes it's called the parent chain, and sometimes it's called the carbon backbone. Carbon backbone, parent chain, main chain. And something just popped in my head here. I was going to read you the answers to that solution test, but I gotta wait because you still gotta take it, right? Yeah, so we'll do that once that happens. Sorry, that was random, but I just thought of it. So back to this. So this is called your main chain, parent chain, or carbon backbone. Why backbone? Because your backbone has things branching off it, right? Legs, arms, head. Same concept. Here's the backbone. This thing is branching off of it. So circle that. This is how we do it every time until we get good at it. Until you get good at naming, I expect you to draw boxes and circles. So let me back up. You count the longest chain, put a box around it. Anything outside the box, we circle, except hydrogens. We don't circle hydrogens, but I don't label them, so it's easier. So if you see a carbon outside the box, you circle it. If you see a chlorine or a nitrogen, you circle it, okay? But it's usually a carbon. So always circle whatever's outside. This is called a branch. That's called, oops. That's why this thing is called a branched alkane. Alkane means single bonds. This is a branch. So branched alkane. Or sometimes it's called a substituent. A substituent, and in real life, not just organic chemistry, the word substituent, from my understanding, means a piece of something larger. So it works. That's a smaller piece of something bigger. So substituent, and there's one more name for that. It's called an alkyl group. An alkyl group. I know these are some weird names. That alkyl group is a weird word. That's just what this is called. The branch, the substituent, or the alkyl group. Questions before I move on? Okay, we're going to go nice and slow through this first example. Okay, so now I have to tell you what this actually is. You're like, wait, I just did it. There's actual names for this. So the best way to explain that, sometimes high schools, middle schools, elementary schools have actual names. So you can say that's the high school, but it has a name too. Like Voorheesville. Voorheesville High School is called Clayton A. Mountain. So 2 different names for the same building. So I'm just trying to give you an analogy off the top of my head. This is called a branch, but it also has a real name too. So branch is just kind of a general name for it. So there's 3 names for branches. This is one type. I'll tell you the other 2. So somewhere near this, under it, to the side, I don't care. I need you to write this. Substituents. So I'm going to give you the names of the substituents. What are those? Branches that are going to come off the main chain. So I'm essentially teaching you the pieces that will be hanging off of chains. There's only 3 you'll ever see. The first one's called methyl. It's called the methyl group. Next one's called ethyl group. Guess what the third one's called?
No idea.
Propyl, very good. Propyl. Guess how many carbons are in the methyl group?
I'm gonna guess 1.
1.
1.
Guess how many are in ethyl?
10.
2. Guess how many in propyl?
17.
3.
No, I'm not 3, sorry.
Methyl, draw this next to it if you have room, hopefully. I didn't tell you to leave space, but next to it, carbon with 3 H's. I talked about this yesterday when I talked about free radicals, or maybe that was the other day. I don't remember when it was. I think it was yesterday. So this here, okay, I know you're writing, but if you can look up here, that's a methyl group. So I just took this H off of methane, so that's a CH3. That's called a methyl group. That's the same thing that's here. That's a methyl group. So that's actually called methyl. That's the name of it, methyl. Okay, that's a CH3, which is also a free radical because it doesn't have a bond, right? How do we combat free radicals?
Antioxidants, blueberries, bananas, apples, oranges, eggplants, about everything.
Fruits and vegetables, yes. Ethyl looks kind of like that, but we have to add another carbon. 1, 2 carbons. And then label our H's. So it's a C with another C. That's called ethyl group.
Mr. McCoy.
Hold on one second. And then propyl, I'm going to just put it under here. I don't have room. Would be 3 carbons, which I don't think you'll see on a regents, but I'm going to teach it anyway because why not? Just in case. Yeah. Question?
I mean, can I spit my gum? I don't want to disrupt or anything, but like.
Can you spit your gum out?
Yeah.
You mean like in the garbage?
Yeah.
Yeah, go ahead.
I didn't want to like walk up.
Yeah, no, that's good because it would have been like kind of
awkward. Like,
well, ruined the momentum a little bit.
Yeah,
I'm like flowing
it still
here.
is though. It
Okay.
still is.
No, it's better. But now we're getting off to craziness. So here we go. All right. So there's your 3 substituents. So let's back up. I'm going slow on purpose, so stay with me. You count the longest chain of connected carbons. Sometimes it'll be 8. Okay, but this time it's 3. Put a box around it. Circle anything that's outside that is a carbon, basically. So you circle that. Now we have to name inside and outside. And we put those names together, and that's the overall name of this thing. So, the name inside the box. Imagine this carbon is not here. What would that be called?
Just be called.
How many carbons do we have? 3.
3.
What's the prefix?
Pro.
It's all single bonds, so
Propane.
propane. So in the box, that's called propane. That's called propane. Now we name outside the box as if it was by itself. So forget the box. We have CH3. We just learned what that is. That's a methyl. That's harder for students. You got to kind of remember that. This is called methyl. We're almost done. Now we have to number our main chain. What does that mean? We have to assign numbers to each carbon. This is carbon 1, that's carbon 2, that's carbon 3. Or that's carbon 1, that's carbon 2, that's carbon 3. You can go either direction because remember, these things really do exist in real life, so there's no left and right, up or down. They're 3-dimensional, they move around, so it doesn't matter how I count, at least not yet. It's going to count on our next example, or it's going to matter in our next example. But for this example, it doesn't matter which way we do it. Let's just say 1, 2, 3. So this is carbon number 2. That's the important one because when I write the name of this structure, it's called this, 2-methyl propane. That's the name of this. let me explain the final name here. On the second carbon, that's what that 2 tells me, on the second carbon of the main chain, I have a methyl hanging off. That's what this name tells me. 2 methyl. So there's a methyl on the second carbon of the main chain. So that's how the name and the structure work together. So hopefully I went slow enough and tried to be as clear as I could. So if I draw another one up here, you have a good chance of trying to name it. Questions on this before I erase it? So nothing really gets any different from here on out. It just gets a little bit harder. Where there's more numbers, longer chains, you're going to have more than one of these. I'm going to draw that before you get out of here. But it's the same concept over and over and over. Find the longest chain, put a box around it, name it. Circle outside, name it, and then you put them together. Okay. I'm going to draw 2 on the board. See what you can do. And your homework, you're doing both. You're naming and drawing, so hopefully with what you learned today, you can do the worksheet. All right. So I'm going to put 2 structures next to each other. Okay, so draw that and then try and name it. And I'll put another one over here. And if we have time, I'll let you kind of converse with your partner, but I don't think we're going to have time for that. So draw those and use the techniques I just showed you to name them. I'll give you a few minutes, and then right before the end here, I'll go over it. The one on the right's tricky because I haven't taught you yet how to do it. Not really. But you can get started. So I'm going to walk around in a minute or so. I want you to humor me. Even if you picked it up, even if you think you're good at it, I want to see boxes, I want to see circles. Because when you're first learning how to do this, it's good to really kind of go slow and make sure you know what you're doing. Good.
Yeah. Oh, there.
Oh, it's been like 2 days since I trimmed it. Good job, Blake. See some boxes and circles, nice and big. Still can't find your notebook? That's unfortunate. Thinking differently. It's good. Everybody does the boxes sideways. But it's the same thing. Good job. A little more time for those of you who are still trying to figure it out, especially this one. I'll give you a hint on this one. There has to be a prefix. What are prefixes? Mono, di, tri, tetra. Or like the meth, eth, pro, but that's not the kind of prefix I'm talking about.
Wait, for which one? Come here. Show me.
The first one?
No, for this one. The second one. What are you talking about?
Yeah, I'm gonna go over it.
Okay.
Well, you have 2. All right, real quick. Let me go over the boxes here. So this one, we should be doing this, and we should be doing that. Okay. This one, Most of you did this, and then you circled those, but you can box the middle and circle the sides. Literally, it's the same thing. It doesn't matter. Okay, so I'm just going to leave it like that. But there's two substituents, two branches. This only has one branch. I'll get to that in a second. All right, Shelby, Pickman, what's the name of this box?
I did 3-methyl-butane.
Oh, so you gave me the whole name. All right, so yeah, that's a methyl and that's butane. Very good. So it's methyl. This always goes in front. Chain or the branch always goes in front. Methyl butane. Very good. And now I set you up for this because I didn't teach you this yet. I'm about to. There's two ways to number this: 1, 2, 3, 4, or 1, 2, 3, 4. This has to be carbon 2. In organic chemistry, the rule is the lowest number possible is what the substituent is attached to. So if you have an option to number that 2 or 3, make it number 2. So the answer to this is 2-methylbutane. So you got to go for the low. Go for the low number there. So you have to count from the right. Over here, what's the name of the one in the box? Propane. I'm just going to write the name, see if it makes sense. 2,2-dimethylpropane. That's what it's called. Here's why. This is the second carbon. It has 2 methyls. That's why it's called dimethyl. 1 methyl here, 1 methyl there. So that's 2 methyls. That's dimethyl. They're both on the second carbon. They both get their own number, even if it's the same number. So 2,2-dimethyl, that's called propane. That's why that one's called that. Bell's going to ring, so we'll have to stop. Hopefully that helps you get your homework done. Okay, so the rest of that worksheet due tomorrow.